Back once again to this episode. Um, we're going to in this episode relate with the analysis that we had done in in the previous episode of a video that we looked at. All right, so we identified in the previous episode the output, the input, and then the processes. Okay, so quickly we're going to go to the development environment. We would create a project and then receive these two inputs, the speed and the number of hours. And then we would graduate on from there in calculating the distance and then putting it in the tabular form as it is here. And then finally, we're looking at how to write this output into a file. All right, so how to create a project, we click on this. If you are new to this, you can go back to the the second tutorial that I prepared. You can look at on how to create a project. Right. So we're clicking on next from here. Let's give this project um a name. We may want to call it, let's say, distance calculator, and finish. All right. So now we want to add a class to the project. So we want to call this um let's say distance, and then we click on finish. All right, so we have created a class. We will need to now have the um the main method. So we specify the signature of the method, public static void main, pass on the string argument to it, RGS. Okay, so we would want to receive some input at the console level. So we want to import the scanner class. So import java.util.scanner. Okay, so in the meantime, this is the library we will need. So this is what we have imported. Let's create an instance of the scanner class. We want to call that, let's say, sc new. Use s is supposed to be an uppercase scanner. All right, so we're going to receive the input from the keyboard. So we use system.in. Okay, all right. So according to the question, we are supposed to receive the input and number of hours traveled from the user. How do you do that? So we want to prompt the user to enter the speed traveled. System.out.print. All right, what do you tell the user? Let's say enter speed traveled. How do you receive this input? All right, so the speed traveled could be having a decimal placing point in it. So we want to make it a float. We call the variable speed. Right? Now we will use the object of the scanner class to have access to the wrapper class. So because speed is a float, we use the float wrapper class. Okay, so we have received the speed, and then we have converted into a floating type, and then we store that into the variable speed. Okay, so now the second thing we need to do is to also prompt the user to enter what? What you said we should enter the time. All right, so time as in hours traveled. So say enter hours traveled. Okay, so hours traveled by the example given in here. The hours could be either an hour, 2 hours, 3 hours, which makes it what? An integer. Okay, so um, make this hours traveled, in short HT, and then we'll still use the scanner classes object SC, and then since this is int, we use next int, oops, next int wrapper class to do the conversion from a bytecode to the entity to type. All right, so now we have received the two input. What are we supposed to do with it? When we have received these two input, we will need to now look at how we can have at each hour the distance traveled. Okay. Now to get that, um, I've been told that distance is equal to the speed times what? Times the hours traveled, which is the time. But we want to get this. Um, we want to get the distance traveled for each hour. Okay, so like in the example, if it has traveled for 3 hours, then we for 3 hours, and then at a speed of 40, we know at hour one it was moving at 40 meters per hour. Hour two, it is 80 meters per hour. Hour three, it is 120 meters per hour. Okay, so likewise means that if you could see it very well here, the the hour starts at 1, it increases by 1 at each point until it has gotten to the exact number of hours that the car had in total traveled. So if it has traveled for 5 hours, then we're going to have moved from 1, 2, 3, 4, and then what? 5. If it had traveled from for 10 hours, then we're going to have moved from 1, 2, 3, 4, 5, 6, 7, 8, 9, and then what? 10. And then at each instance of these hours, we are calculating the distance it has what? Traveled. Okay, so now the key point in here is that we understand to get the distance traveled, we should have we're going to use the speed times the hours traveled, which is represented over here as HT. Okay, so let's put a loop right here. Ooh, using the for loop is much easy, so we use the for loop starting at hour 1, I to represent the count at 1. I should increase at each point in time until it is equal to what? The hours traveled. Okay, so I plus plus. It should do this. Why do we have this above here? Variable declaration not allowed here. Okay, no problem. So we can copy this and then paste this outside of the loop. Let's take off this. Okay, great. So we have resolved our problem. Let me save this. Okay, so going back again to this side, so what we will need to display, let's put this in bracket because we're going to have more than one line of code that should be executed when this condition holds true. Okay, so we'll do the calculation and then we say in that it should print system.out the distance anytime it picks the what? The sorry, this should be I and then not HT. Okay, so to print I plus let's leave a tab in here. Okay, so by the output we're supposed to have, we should have at each hour and then a distance traveled. Okay, so in our case, in the loop I, which is the counter starting at representing hour, should start at 1. Okay, so when um uh, it's 1, we check it's 1 less than or equal to the input. So like in the example 3. Okay, whilst that is true, it comes to this side. So speed is 40 in the example. I is now what is 1. That will give us what 1 times 40. So distance will be containing the value what 40. Okay, so we want to print I, which is what 1 now. We leave a space that is tab, and then we print what 40. Okay, so the control moves back again to the incrementer. The incrementer increases by 1. Okay, when it increases by 1, it needs to check this condition. So we started with I equal to 1. Now when I has increased again by 1, what do we get? We get 2. So we check is 2, I containing 2 is 2 less than or equal to 3. 2 is less than or equal to 3. 2 is less than 3. That makes it what correct. Okay, so now we take speed which is 3, and then I, which is what 2, and then we multiply. What do we get? 40 times 2 is 80. Okay, so distance now contains what 80. So we print I, which is 2, and then distance, which is what 80. It goes through this side again. I increases by 1, and what do we get? We get 3. Is 3, I is now containing 3. Is 3 less than or equal to ht? Ht's value does not change. Okay, ht is still 3. Is 3 less than or equal to 3? 3 is not less than 3, but 3 is equal to 3. So to come back again, taking the value of speed is what? Is 40. I is now what? 3. So 40 times 3 gives us what? 120. So distance now contains 120. So over here, distance will contain 120 to print 120. And what is the value of I? I contains the value what? I contains what value? 3. Okay, so let's look at this. The control shift back again to I plus plus. I increases by 1. What do we get? The last time before it got to this side, it was 3. So now I will become what? 4. Is 4 less than or equal to 3? 4 is not less than 3. 4 is not equal to 3. So the condition is no more what? No more true. Okay, so then the loop breaks out. Okay, so let's quickly run this code and let's see the output. Okay, so enter the speed traveled. So we use the same values as it is in the code. The speed traveled is 40 meters per hour, and then enter the hours traveled 3. What output do we get? Okay, so we get 1. At hour 1, it is moving at 40 meters per hour. At hour 2, it is moving at 80 meters per hour. At hour 3, it is moving at 120 meters per hour. Okay, so now we have not modeled it to be exactly as it is here on the table. Okay, so stay on, and then in the next episode you will see the finishing of this code. Thank you. If you have any questions as well, you can leave